Hope you're all doing well. Let's see. I did score the exams, posted just the scores. I will be uploading the raw exams with all your work and such probably Thursday morning. I might sleep in a little bit because it's Thanksgiving, right? So, but anyway, Thursday I'll get them up to you. Um, and overall, results look good, and you'll see for yourselves. There was a couple questions, just like that, the one with the natural log, integrating that. If you didn't get the right start, it was like hard to get much for it. So anyway, take a look at how you did, and we can talk about those next week. So we have class today. We do have class on Wednesday, but with this sort of turnout, I think maybe half of you might be here. So it might be light, but actually Wednesday will be a fairly uh, is a little bit more than what we're going over to today. So it's 414 on surplus, gets into some economics, uh, but it's a very good business application. Again, it'll be recorded so you can take a look at those. Um, but we've got our last three units. We'll do 14.5 when we come back, and then we've got review, and then we've got the following week, we have our final exam. If there's an interest during finals week, I'd be happy to set up some kind of a review session, either online or reserving a classroom somewhere, finding one. So just let me know if you send me a little message of what you're interested in. We'll see if we can make it work, maybe like on a Monday or Tuesday, or even a Wednesday, I guess. So we'll see how that works out. Let's see. So we've got 14.3 average. I guess before we get into this one, are there any questions or concerns, or all good? Okay. Also remember the final exam is on Thursday night of finals week, so it's a common final. So you'll actually be taking it in the same room with my Tuesday, Thursday morning class. So they give them both to me. So we'll all be in there 7 o'clock p.m. till 9 p.m. on Thursday night, December 7th. Is that right? Yeah, whatever that Thursday is. So take a look at that. And there's a little map I did because I don't think I've ever been to that building, but we'll figure out where it's at and get to the room. And um, just well, I guess it's not real critical. We all give the same final, but I have had sometimes when I have these common finals, some of my students get into another classroom, and it's a Math 170 or one, so it's a similar class final. Um, they forget what I look like, or they think it's a TA. So if that happens, then we've got to share exams. We may have someone, but anyway, try to get to the right room when we get to that point. Also, I guess before I go too far, there is this journey to the final. So this final preparation. I guess I'll go ahead and turn exam 3. This is actually the exam 3 from spring semester. So I'll turn that on so you can see it. I think. Oh, publish. So I've got exams 1, 2, and 3 with just solutions. They're not videos, but I've got my solutions in there. Those are spring exams. I'll post the ones from this semester, but there's some good reviews in there, some study guides that'll be helpful to get you ready for the final. So if you've got time, take a look at those. Okay. Today is like should be one of the easiest concepts to pick up. Okay, because so we'll be using the FTC, Fundamental Theorem of Calculus, which is we're going to integrate over two boundaries, right? A starting point and an ending point. But in this case, what we want to do is we want to get an average. So let me just give you an example. I think they do a little bit in here. But if I drive 200 miles in 4 hours, can you tell me my average speed? 200 miles in 4 hours. What would be my average speed? How would I do that? 50. How'd you get it? Very good. So you took the value, which remember when we integrate, we got a rate, we integrate it, we get a value. To get the average, we started at time 0, we drove until time 4 hours, t0 to t4. So we divide by 4 minus 0, which is 4, and we get 50 miles per hour, right? The 200 is actual miles. The 4 hours is hours, is time. So when we divide them, we get time. And that's exactly all we're doing today, okay? What we're going to do, though, is this, the 200 is going to come from some kind of an integral, going from 8, well, in this case, 0 to 4, of some function. I'll just put f of x, or f of t maybe. And what we're doing is we're multiplying by 1 over 4 minus 0. Okay, so in general, we're going from time A to time B. We're integrating some function, which remember is a derivative, and I'll put the derivative of this function to indicate that that's what we're doing. So this is what we've done before. But to get the average, the only thing that's new is we're going to take 1 over, or we're dividing by the interval, the length from B minus A. Okay, that's all that's new today. So it's not really, so there's no real new skill. We're just like you said, don't you just divide by 4? Exactly. That's all we're doing today. But we'll look at how that, looks on the graph and all that kind of stuff too. But if you got that part, that 200 miles in 4 hours, 200 divided by 4 is 50. That's your average speed. You understand we're not driving 50 miles an hour all the time, right? Sometimes we're driving faster, sometimes we're driving slower, but the average is kind of, if you put it all together. Good. Okay. So here's a little bit more mathy way of looking at it. How do we find the average? It's to find the average of, say, 20 numbers. You add them all up and then divide by 20, right? So got a bunch of numbers, add them together, divide by however many there are, and that's what we call the average. So we are dividing. And thinking of Riemann sums, that's sort of how we got to the idea of an integral anyway. So we added all those together, and then we could, get the average. And so they've got some numbers down here. Notice none of these numbers is exactly 1.5, but if you add all these numbers together, since there's 4 of them, you divide by 4, the average is 1.5. That's what we're talking about, okay? Here's their example, maybe a little bit easier. 2 hours, my speed varied from 50 miles per hour to 60 miles per hour following this function. Okay, so this one's going to be a little bit more realistic. So we're not driving at a set speed. From 0 to 2 hours, what was my average speed over those 2 hours? So what we're going to see is we will get, this is giving us our velocity at any given time. If we integrate this, right, this is velocity, and what are the units on velocity? And it's on speed. Miles per hour. There we go. So miles per hour. Okay. When we integrate, what are we going to get? We're going to get just miles, right? Remember, we've talked about it. We've got a rate, a derivative. When we integrate it, we don't get a rate anymore. We get the value function. We're going to get the distance function. We won't have velocity. We will have the position functions, which will tell us how far we went. Okay. So, and notice I didn't delete this part. They will give us the distance traveled. So let's integrate this because, again, this is where we get some practice of what we've done previously. When we integrate 50, what do we get? Since we're integrating with respect to t, don't we get just 50t? Yes. We integrate 2.5t squared. We're going to get 2.5 t to the third divided by 3. And this is going to go from 0 to 2, not plus a constant, because we need. So this is how we use the fundamental theorem of calculus to integrate. And I know on the test it said something about use the fundamental theorem of calculus, and some of you said, when did we? I don't remember this name. I know I said it a few times, but it's this is the fundamental theorem of calculus. So it's just integrating this, okay? So we plug in the 2. Notice if we plug in 0, nothing's going to happen. You get 0. So this is going to become 50 times 2 plus 2.5 over 3 times 2 to the third power minus 0, because if you plug in 0 to both of these, you get 0 plus 0, right? So we don't even have to worry too much. Let's see. Let's plug that in and see what we get. Well, 50 times 2 should be 100, right? So that's not too bad. 2.5 divided by 3 times 2 raised to the third power, which is 8. So it's 1,200 plus 100. I get that this whole thing here is 1,306. Really? Oh, no. I pushed the wrong button. 2.5 divided by 3 times 2 to the third power, 6. Yeah, this I was going, wait, that's moving pretty fast. 6.666 plus 100, 106.666. Is that more in line with what you got? Okay, okay. So that's the distance traveled in 2 hours. Now, if we wanted to find the average speed, wouldn't we expect it to be between 50 and 60? Because we were driving between 50 and 60. So we'd find out whether we were closer. We would expect this average to be somewhere between there. And again, we would get that average because it's over 2 hours by just dividing. So this is an average calculation, is going to be that number divided by 2 minus 0. So you'll always do the end point minus the starting point. Okay, 2 minus 0 is just 2. We could just leave that off. But I want you to remember, if we started like an hour into this, it would have been 2 minus 1. And so we divide that by 2, and we get about 53 point something, right? 106.666 divided by 2. Yeah, that gives us that our average is 53.33. And what is it? It's miles per hour, because what are these units down here? 2 minus 0. These are hours, and this is miles. So again, we integrated, and we went from a miles per hour. So when we integrated, we got just miles. But when we get the average again, we're dividing by those units of time. So we're back to miles per hour. Okay, so that's sort of a disconnect that doesn't always make sense here. But we are starting with the derivative. We're integrating to get a value. But when we get the average value, we're actually getting an average rate, right? So the average takes us really kind of back to the derivative in a sense. And they work it out here. This is what we did. Integrate, that's what they got. Plug it in. We got the same thing, except instead of 20 over 3, we put 6.666. We just divided it. Now they do it. Since it took 2 hours, let's divide by 2. That gives you your average speed of 53.3 miles. Okay, that's what we're doing today. Okay, so we're going to integrate something, get to value, but if we want the average of what happened, remember an average gets us back to the rate. Okay. So in general, the only thing that's new today, other than maybe the concept of what's happening, is to get the average. We're going to integrate, which we've been doing, right? We've been doing this part, even added on the test. Second, the new step is we're just dividing by the length of the interval of time. And that gives us an average speed, gives us an average. So the mathematics isn't too much additional. It's just, and I remember when I learned this, I said, why do we even have to study that? Like, could have just, but it was one of my favorite sections because it was stuff we'd already learned, and then just take this average. Okay. And so we could work through one. It's the average or mean function. So they give us an example here. If we've got the function is f of x equals x, or, again, y equals x is a function from 1 to 2. We integrate from, 1 to 5. Then we're going to integrate from 1 to 5. But since we want the average, we're going to end up dividing by 4, 1 over 5 minus 1. Right? And that will give us an average. And again, when we integrate, we start with what's a derivative, we integrate it, we get that as a value, but the average is going to be something per hour or something per unit, something. So we get back to an average derivative, so, and again here, let's see, 25 halves minus 1 half is 24 halves, which is 12. So the value, the total amount of stuff that happened, if this was cost or whatever, is say like $12. But what it's saying is over that interval, over that 4-hour interval, on average, $3 was spent. Okay, so this is a kind of an, this, what we're getting at average is sort of a rate. And again, we don't know if it was, there might have been more spent at the end or the beginning or different times, but this just gives us an average of way of thinking, how did it turn out on average. So we're going to look at a few graphs, and again, this is just kind of showing what the average looks like. So the function that we just looked at was going from 1 to 5, y equals x, so that's, sort of triangular shape, or I guess you call that a trapezoid, but it's got this shape. But what does the average look like? Average is just a horizontal line, so it's y equals 3. So you kind of see it sort of cuts this part here, tucks it down there, and just sort of averages it out, makes it like it was a rectangle. Okay, so that's all the average is going to do is make it so that the area under the curve is a rectangle. Same amount of area for the blue as much as the pink, but that's all the average is doing. Taking the highs, putting it where the lows were, evening it out. And if we've got a function that's kind of, wavy, what the average is, again, it's going to fill the lower parts with stuff from the higher parts. It's going to have the same amount of average, but the average is always, if we graph it, is going to be a rectangle. Okay. So it's a way to think of what's happening on average. Again, we know it's not that every hour, but on average, we can say this is what's happening. course, it doesn't do you any good if you got stopped for speeding to tell the officer, well, I was averaging 55. Is that okay? I happened to be going 75 at the time, but my average, no, they don't buy that. Okay, so let's work through one together. And again, that's all we're doing is we're still setting it up like we did in previously. We just have to take the derivative function, integrate it, and then we're getting a value. And then we divide by the interval of integration. Okay, so we've got a savings account at the People's Credit Union. They pay 3% interest, compounded continuously. At the end of the year, you get a bonus of 1% of the average balance in the account during the year. So sometimes this happens. What's your average balance? Just thinking, a lot of retirement programs, they base if you've got a benefit-based program, like the state of Arizona, they base your retirement income based on the last 3 years average. I think they changed to the last 5 years recently, but they take your last 3 years average salary and they use that as a calculation. Okay, so it's standard to do this sort of things. So we deposit $10,000 at the beginning of the year. How much interest and how large a bonus will you get? Okay, so they're going to work through this, but since they compound continuously, there's a formula which is the accumulation is equal to the original deposit. They call it A naught E to the RT. So we can use this formula. What's our deposit? I don't think I have anything down here. I'll erase it if I did. We deposited $10,000. We multiply by E. R is the rate, which is 3%. So we put that as 0.03, and T is time. And this will give us our accumulated value at any given point after however many years. Let me take a quick peek. Okay, yeah. Okay. So if we want to find the average value of this using this function, an account during the year. So we start at time 0. We're going to go for 1 year. We could go on for 2 or 3, however many years it's going to go. This will get us our accumulated value. Notice this is the rate. And then if we want the average, we're going to divide by 1 minus 0. 1 over 1 minus 0. Okay, so this will give us the average balance. Okay, so when we integrate this, we're going to get 10,000 e to the 0.03t, because it's its own integral. But when you take its derivative, the 0.03 comes down, so we need to also divide by 0.03. So they have a shortcut rule that kind of shows this, right? Whatever the rate is, they use this as A. When you integrate it, you have to divide by this constant here. Okay. We're going to take this from 0 to 1, and we're also going to multiply it by 1 over 1, which is still 1, but that'll give you the average for the year. Okay. If we wanted it over 2 years, it would be 1 over 2. 3 years, 1 over 3. Okay. And so this gives us 10,000 e 0.03 times 1, right, for 1 year. I guess I should do that here. Remember, we have to minus off. We plug in the 0. Now, be careful here. The 0 doesn't make this all disappear. This is 10,000 e to the 0.03 times 0. And divided by 1. So get that right. Let's see. Yeah. I get 34, 38, 34, 3. And then here, e to the 0.030, that becomes 1. So it becomes 10,000 over 0.03. Which is 333,333. And when you subtract those two, long way to get to 10,151.51. And again, we divided by the length of the interval, which is just 1, but that would be our average balance for the year. Okay, so integrate, and then so if you just put e to the 1, you get this. So this would be your balance. You made $304.55 in interest. So that's actually the balance you'd have at the end of the year, right? 10,304. And we look at our average. It's about half of that 300, not quite half, but so again, to get the average, we're going to integrate from the start to the finish, and then we divide by the end minus the beginning. They factored those out and just did the long calculation that I did the steps on. You plug in the 0 or 1, plug in the 0, subtract, and you get this is your average for the average balance for the year. Okay. Now, it seems weird that it's also, but that's how the average balance. So we integrate, and then we multiply by dividing by how long that interval is. And when you divide by 1, it doesn't change anything, but you would get a bonus based on your average balance, so 1% of this amount, so this times 0.01 gives us $100, $101.52. Okay, so just whenever they ask for the average, you have to divide. What I wanted to do is do the same problem, but what if we wanted the average from year 2 to 3? Well, let's make it more interesting. From year 2 to 5. And continuously compounded at 3%, we put in $10,000, but we're not really caring about what happens in those first 2 years. But what's this going to give us? It's going to give us the accumulation over those year 2 to year 5, the balance from year 2 to 5. And since we want the average, we would take 5 minus 2. And notice that's going to give us 3. So what it's going to give us is the accumulated value for those 3 years, balance for those 3 years. We divide by 3, it will give us the average of those 3 years of balances. So again, we did this sort of before. 10,000 e to the 0.03t. We just integrated this, right? E is always its own integral. However, when we integrate, we divide by this rate, 0.03. Again, sort of using the shortcut rule. You could also do this with u substitution, but as we get to the end, it's something like this. It's a lot easier to use the shortcut rule. We're going to get the values from 2 to 5, and we're going to multiply this whole thing by 1 over 3, which is 5 minus 2. And let's see what we get. Actually, well, let's go ahead and open this one up. Might take a moment. Okay. So I'm going to do this one graphically just to kind of, so we get a C. We're going to put in our function, 10,000, 1, 2, 3. E 0.03 x, and I'm going to integrate this sort of graphically. So we know it's going to go from year 2 to 5. So our window is going from -10 to 10. So let's go from 0 to 7. So 0 to 7 years, we'll see the whole graph. The y values is how big is it getting. Remember, we're putting in 10,000, and it's growing from what we saw before at 3%, about $300 a year. So over 5 years, it should, maybe 11,000 should be big enough, but let's go maybe 12,000. And we should be able to see the graph, so I'm going to graph it. And we do. Maybe I should go a little higher. But see, this is the graph, the rate of the money. And so over the years 2 to 5, oops, I can go second calc. Lower limit is 2, year 2. The upper limit is year 5. There's that. So it tells us on average our balance over those from year 2 to 5 was, oh, well, no, we're not the average yet, right? That would be the total of the balances. To get the average, we'll take this number, 33,332, and we divide it by 3. Remember, we got that 3 from 5 minus 2. So we have an average balance of about $11,111.11. Okay, so that it was higher at the end of the 5th year than it was at the beginning of the 2nd year, but if we were to average it out, that would be the balance we would have. Okay, so kind of a mix of, using our calculator to do the integration. Come back here. We also, if we would have integrated this by hand by plugging in 5 and 2, we would have got the result to be 33,333.33, and then we would multiply that by 1 over 3 to get the average. Over that time period. Good with that? Okay, so what time is it? 3:40. Still got lots of time, so let me just take a look at the WebAssign homework, just see where we're at. Incidentally, I have extended all of the previous homework assignments, and actually even the current ones. I just moved everything to December 8th. So all the homework is available to you if you want to go back and work on anything you didn't finish up. These current things are not due till the 8th, but remember her test is on the 7th, so yes, you can still work on it the morning of the 8th, but it's going to be better to kind of do them as we go. But at least due dates for the homework won't have any impact. And I did update homework scores, so take a look at the grade book and see where you're at. Make sure everything came over correctly. We're in 14.3, is that right? Yeah. So there's only 6 questions here. Let's just see. So yeah, not too bad. They give you a function to integrate. They give you the limits, 0 to 2. And so partly what you're going to do is also, once you calculate it, you have to pick a graph that demonstrates. So they give the graph of the function and the graph of the average, right? Graph of the average is always going to be horizontal. But I think you'll be able to match these up. Just like we could come back here, since this is the average, right? So see, there's the average. It takes this extra up here, puts it back down there, right? So that's, we talked about what the average does is it kind of makes a rectangle for the same amount of area. And see, so that up stuff goes back down there. You could kind of see that if I were to take the area under the curve of the red one, so I'm going to go second calc. Let's see, I'm on that one. I arrowed down, that should put me on this graph. I go from 2 to 5. And notice how the red rectangle has the same amount of area as the blue rectangle, 33,333. Okay, so average works out. So just recognize them visually as well. A couple different ones. Here's some different. Yeah, so once you get that average, you can graph it. It's going to be a horizontal line. Not too bad, e to the x from -1 to 1. And a couple of application problems. Here's another compounded continuously. So like this question we just did, it just has different parameters, $2,000 at 8%, but you'll use that same formula, e to the RT, right, times that. So do that same thing here. This will be similar. They're giving you a cost function. You want average cost, and you're all good. Wednesday, we'll pick up with surplus, consumer surplus, and producer surplus. And what that is about is it's using the calculus is if a company charges a lower amount for a product than they could get, what they've done is, because if you charge a lower price, you get more people buying it right away. So what that does is and you're charging less than people would be willing to pay, it gives a surplus in the economy for the consumer. Consumers have more money in their pocket because they were willing to pay $100 for this, but you charge them 75. They got an extra, in their view, they've got an extra $25 in their pocket. So we'll look at that. Also, it works the other way around. So there's a producer surplus, there's a consumer surplus. And how many of you are into economics or have a strong economics back? No? Oh, not strong economics. Okay, well, stronger than I am, I'm sure. So if you're into economics, this is you'll probably have a better understanding than most of us, better than me anyway. So I slept through most of my econ classes and never went to the second one. But there's micro, macro, and whichever one I took first blew me away. So I didn't go take the second one. So anyway, you'll be able to help us with that. And then next week we'll pick up the last section, but just kind of stay tuned and keep moving forward. Let me know what you need. And again, I will get exams scanned and uploaded so you can see exactly how things worked. And I'm happy to meet with you, discuss your exams or where you're doing, and work towards the end. All right, thank you.